Good evening, everyone. Welcome to this live session on 29/7/2026. Okay, so this week we'll be discussing week 7 content. Okay, so week 7 basically it's all about frequency response. Okay, frequency response. Previously, when if you remember in the starting modules, so I think week 3 or week 4. Okay, so week 3 or 4, okay, you have time domain response, correct? You have seen the time domain response. Wherein which you have considered the first order as well as second order systems, correct? Okay. So for both first order and second order, so you have drawn the time response as well as you have defined uh, different specifications like rise time, settling time, steady state error, and overshoot, peak time, etc. Correct? So these are various specifications we derived, and we have been using these from module 4 onwards. Okay, so now in this week 7, okay, so in the similar way, so time domain response, we have something called as the frequency domain response. Okay, in this also we'll be defining the parameters. Okay, so majorly here in the frequency domain response. Okay, so I don't want to repeat the same content what Sarah has covered. Instead, uh, you should get clarity on solving the problems. So that's why I'll enter the problems directly. So basically, what we do here is uh, so week 7 majorly it talks about two things. So in the frequency response, okay, Bode plot as well as the Nyquist plots. Okay, Bode plot and Nyquist plot. So we'll try directly consider two problems, one for Bode plot and one for Nyquist plot in this slide. Okay. Then before coming to the next slide, you can solve a couple of problems, and then you can ask me any doubts, right? And also we'll continue solving the problems in the next live also. But my aim is to give clarity on solving the problems, one with Bode plot, another with Nyquist plot, so that you'll feel comfortable to solve the extra problems. Okay. So let us consider first Bode plot. Okay. So I'm not explaining the theory behind that. Once we solve the complete problem, you'll understand what it is. Okay. So Bode plot. Okay. So example. Okay, so let us consider, okay, so the g of s, so the transfer function, so that is k s square divided by, so 1 plus 0.2 s, okay, so let's say 1 plus 0.02 s. Okay, let's say we have two zeros as well as the two poles. Okay, so now the question is like this. So sketch Bode plot, first question, okay, using this transfer function, and also find gain k, system gain k. Okay, so for the gain crossover frequency of gain crossover frequency of 5 radians per second. Okay, these are the two questions. So we'll see what exactly this gain crossover frequency also is. Okay, first if we understand how to draw the Bode plot given a transfer function, so the rest is easy. Okay, so in this we'll go stepwise. So let's say step 1. So by the way, if you get any doubt, you can directly ask me because these steps are very important. Okay, now we have, um, let us say you have this g of s. Okay, so k s square by 1 plus 0.2s multiplied 1 plus 0.02s. Okay, so how does it looks like? It looks like k s square by, okay, 1 plus s t1, okay, then 1 plus s t2. Okay, directly you can identify what are these t1 and t2, correct? Now, so replace j with j omega, because we are doing the frequency response. So g of j omega equivalent to a, so j omega square. So 1 plus 0.2 j omega. So 1 plus 0.02 j omega. Okay. So now let us consider let k is equal to 1. Okay, you'll understand why we take the k is equal to 1. So then our equation would be like this. Okay. So same thing with k is equal to 1. Okay. So is this clear? Any doubt here? Any doubt? Any doubt or query here in this?
Here the T1 and T2 is
Sorry,
0.2.
just a minute. So T1 is 0.2, T2 is 0.02. Okay. So that form looks like that. Okay. So the first step is replace S with j omega. Okay. Next, second step. So step 2. Okay. So here what we do is we form a table. Okay. So I'll let me write that function again. Transfer function. Okay. So we don't have k. So this is v of j omega. So now we form a table. So let us say serial number, term, we say something called as the Carnot frequency. Okay, so which is radians per second. Then we say slope in radians per second. Okay, then finally change in slope. Okay, so that is dB per decade. Okay, so we found this table first. And then using this table only, we will draw the Bode plot. Okay, so now if you see the transfer function, how many terms we have? So we have 3 terms. Okay, so first one is the j omega square. Second one is 1 by 1 plus 0.2 j omega. Okay, so the third one is 1 by 1 plus 0.02 j omega. Correct. So here, so kernel frequency we cannot define for this because it is the 0. Okay, so for pole we define the kernel frequencies. Okay, so omega c1 and omega c2, it is the inverse of the time t1, so which will be 5. Okay, this is inverse of the time t2, which will be 50. Okay, so is this clear? Any doubt? Okay, next, slope. So whenever you have 0, okay, it will give you plus 20 slope. Okay, then here you have 2 zeros. So plus 20 and plus 20, it will be plus 40. Okay, so how it is the plus 20? So please watch the video. You'll understand from that. Okay, now, so whenever you have the pole, so slope will be minus 20. Since you have one pole here, okay, at minus 0.2, so that slope is minus 20. So similarly, the third one is also another pole. So it will add another slope of minus 20. Is this clear? Always in 0 will add a pole of 0 will give you a slope of plus 20. Pole will give you a slope of minus 20. Okay. Now slope change. Okay. Since we are coming from somewhere to this 0, so we cannot define that slope change here for the first one. Next. So for the second one, we wanted to see what is the slope change is coming from here to here. Okay. So for that, what we do is we take plus 20. Okay. Then we add this minus 20. So it will be 20. Is this clear? Any doubt? Any doubt? Okay. So from previous step to this step, what is the slope change? Okay. Plus 42 minus 20, that will be plus 20. Okay. Next. So next we take this slope change from here. Okay. So that will be 20. Then plus this will be minus 20. Clear? So what is the slope change now? It is 0. Is this clear in this table? Do you have any doubt? If you have any doubt, please ask me. Because this slope change, you should understand properly. Okay, this is step 2. Okay, step 1 is replace S with J omega, K is equal to 1. Step 2 is from this table to find what are corner frequencies, what are the slopes they are offering, and then change in the slopes. Okay, next step 3. Okay, so in step 3, what we do is, okay, so how many frequencies we have? We have 2 corner frequencies. Okay, so we start with a frequency which is very, very less than the first corner frequency. Then we go to first corner frequency, then we go to second corner frequency, then we take the higher frequency greater than the omega C2. Okay, that you'll understand now. So first choose a low frequency. Okay, low frequency. Okay, so that, okay, so low frequencies, so low frequency omega L is less than omega C1. Okay, you are simply choosing one frequency which is very less than the omega C1. Okay, so what we can choose here, what we have is omega C1 is 5. Okay, you take something like let omega L, it will be let's say 0.5. Okay, so the lesser frequency. I hope this should be clear. Okay, then next find out the magnitude A. Okay, so what is the magnitude? Magnitude of your transfer function. Okay, at j omega, that is in dB. Okay, so which is equivalent to, if you convert, log 20 log transfer function. Again, so why this 20? Okay, so that is the question which you need to see in the video. So why we are taking 20? Why not we are directly drawing the mod z of j omega? Why we are drawing 20 log? Okay, so now, so this is our magnitude. Let me call this as the magnitude. Okay, so now at omega L equal to, so what we are trying to do, what is omega C1 is 5. Okay, omega L, I took 0.5. What does it mean? So 0.5 is how much percentage of 5? Is it 10%? 20%? 10%, correct? So that's the thumb rule. So we take omega L as 10% of omega C1. Okay, so this is thumb while drawing the Bode plots. Okay, so now omega L is equal to 0.5 radians per second. So using this, we can find 20 log mod So j omega whole square. Okay. So directly we substituted that expression only. Okay. We could substitute at that. No, this has to be z of j omega square. Okay. That has to be z of j omega square. So, just a minute. Yeah, correct. So this has to be j omega whole square. Directly we take that term only. Okay. So that is first thing. Okay. Next, what we do is, okay. mm, so you consider this z of j omega. So if you take the magnitude, okay. So what is the magnitude? So we have this expression. The magnitude will be like omega square. The below one you'll have a 0.2 root over 1 plus 0.2 omega square plus 1 plus 0.02 omega square. Correct? So that we will write. So this will be like omega square plus, so root over 1 plus 0.2 omega whole square. Okay. So root over 1 plus 0.02 omega square. Okay. So this should be clear. Okay. Any doubt in this? Any doubt in this? Okay. So now, I'm sorry, here this has to be omega only. This has to be z of j omega. Okay. So now if you substitute here, okay, so omega is equal to 0.5. Okay. So then you will get this one as the 20 log. So this value. So let me write it directly here. Substitute omega is equal to 0.5 in this expression. Okay. So you will get this value. You will get this value. Okay. So then substitute that value here. So you will get minus 12 dB. Okay. Minus 12 dB. So that is first one. Next, what you do is, next, next what you do is, so consider omega C1. Okay. So here this is omega is equal to omega L. Here consider omega is equal to omega C1. Okay. So what does it mean? Basically, so you take omega C1 as radians, 5 radians per second. Okay. Again, find the same thing. So 20 log mod. So z of j omega. So at that time, omega is equal to 5. Clear? So now if you do that calculation, you'll get 28 dB, the value. I'm giving that value directly here. You can check it later. Okay. Is there any doubt here? So we are finding the two expressions. We are finding this one, or you can say magnitude of A at omega is equal to 0.5. Omega L is 0.5 and at omega C1 at 0.5. Sorry, 5. So you will get first one is minus 12, second one is 28 dB. Clear? Okay, that is step 3. Is there any doubt? Okay, ultimately, what we are trying to do is that, okay, so we start with omega L, omega C1, omega C2, and omega H. Okay, this is low, this is high. Okay, at all frequencies, we'll find this A value. Okay, now, next step 4. So in step 4, what we do? So now at omega is equal to omega C1. Okay, so calculate the A. What is omega C1? That is 5. Okay, calculate A. So that will be like 20 log mod z of j omega. That we have already calculated, which is 28 dB. Okay, now at omega is equal to omega C2. Okay, what is omega C2? That is 50 radian per second. Okay, now calculate A. Okay, so you will calculate this A. Okay, so using using something similar to y is equal to mx plus c. Okay, so that will be like A at omega is equal to omega c1 plus the slope. Okay, slope from omega c1 to omega c2 multiplied log omega c2 by omega c1. Okay, it will be like y is equal to mx plus c. Okay, x is this log term. Okay, now you can see this is already 28 plus. So the next one is what? So 20 log. So omega c2 is 50 by this one is 5. Okay, you'll get what? 48 dB. Okay, you should see exactly. Okay, so this will be like slope multiplied by 20 log this one. Okay, here the slope is 20. Okay, so this is like change of slope. Change of slope from omega c1 to omega c2. What is that change of slope from the table? So that is plus 20. Is this clear? Is this clear? By using the change of slope, we just substituted here. Okay, so we got 48 dB. So that is step 4. Okay, now step 5. Okay, here what we do, so choose a high frequency component. High frequency such that omega h is greater than omega c2. Okay, so let's try to choose that omega h is 100 radian per second. So the question is why 100? Okay, omega c2 what we have? Omega c2 is 50, correct? So now 100 means what? Okay, omega c is almost equivalent to 2 times omega c2. Am I correct? So this kind of that is kind of a standard step. Okay, so the lower frequency will be 10% of the first cutoff frequency, corner frequency. The higher frequency will be 2 times the last final this one omega c2. Okay, so consider this is like thumb rule. Usually we choose like this. Okay, so you can also choose the other values. It has to be greater than omega c2. That's all. Okay, now what we do? So
So
yeah,
you took the value of omega L randomly, correct?
no. Omega L 0.5. So that is 10% of that. So that's why I said thumb. Sorry. While doing problems, whatever the omega C1 you get, take the 10% of that. Okay. Omega L will be 10% of that. Is that clear? And omega C2 will be 2 times of, sorry, omega H will be 2 times of omega C2. Okay. You can also take more than that, not an issue. But in general thumb rule, we follow like this. Okay. Is it clear?
Yes, sir.
Yeah.
Yes, sir.
So now at omega h, we need to find the value. So already at omega is equal to omega c2, we have already calculated how much it is, 48 dB. Okay, now at omega is equal to omega h. Okay, so that is at 100 radian per second. What is the A value magnitude? That will be like in the same procedure. So A value at omega is equal to omega c2. Okay, again same slope from omega c2 to omega h. Okay, multiplied log omega h by omega c2. Okay. Again, what is this? This is the slope, change of slope, change of slope from omega ct to omega h. Okay. So what is the answer we get here? This is already 48 plus. So change of slope is what? From the table. So that is 0. Correct. So that is how we are using the table. So plus 0 multiplied log omega h is 100, omega ct is 50. Okay, we get what? 40 dB. Okay, is this clear? Is this clear? Any doubts? Any doubts?
Sir, I'm little bit confused by taking the
Yes.
values of the variables.
Variables of what? Which variables? So let me show you from step 1 onwards. Step 1 clear?
Yes, sir.
So step 1 clear. Okay. Step 2 forming this table. Any doubt?
No, sir.
No. Okay. So step 3, you have to choose omega L, which is just 10% of omega C1. Okay. So here omega C1 is 5, 10% of that is this. At that, we are calculating the A. Okay. Similarly, at omega C1 also, we are calculating A. This one. So this is minus 12 and this is 28. Clear? So our ultimate job is to find the A for all these 4 cases. Okay. So here we are calculating A at omega C2. Okay. Then here we are calculating A at omega H. Clear? So now we will draw the Bode plot. Before drawing the Bode plot, okay, we will also uh, write the phase information. Okay, what is the g of j omega we have? Okay, so that is so j omega square plus so 1 plus 0.2 j omega 1 plus 0.02 j omega. Am I correct? Okay, so the Bode plot basically is of drawing two things. Okay, so Bode plot. So to draw two things. So first one is magnitude plot. Okay, second one is the phase plot. Okay, so whatever we have done previously, those calculations we will use for magnitude plot. Now the phase plot, what we need is we require the angle of this. Okay, so basically this we call it is as a phi. Okay, so now if you see here, so we have the numerator as well as the denominator. Okay, so let's say if numerator is only yes. Okay, numerator is only yes. Okay, what is the angle it can provide? It can provide an angle of 90 degree. Am I correct? It can provide an angle of 90 degree. How it can provide angle of 90? How I am saying that? Can anyone tell me? So let us say if you consider g of s is equal to s. Okay, substitute j omega. What do you get? J omega. Am I correct? How does this looks like? 0 plus j omega. Am I correct? Yes or no? What is the angle? Angle for a complex number of a plus jb. What is the angle? Tan inverse b by a. Am I correct? What is b here? Omega. What is a? 0. What is the angle? Tan inverse infinity. What is the angle? 90 degrees. Yes. Similarly, if you do the same thing for g of s is equal to 1 by s. So can anyone tell me how much you will get? Angle, how much you'll get? Minus 90. Okay. So now here you have two zeros. Okay, so two zeros, that will give you 90 plus 90, 180. Okay, so you have two poles. Okay, here one pole is giving minus 90. You have two poles, but they are not S, they are something else. So that will be like tan inverse of zero point 0.2 omega minus tan inverse of 0.02 omega. Is this clear? Step? Any doubt? Any doubt? Okay. So now what we do is simply we again form a table. Okay. Serial number, omega radians per second. Okay. So we calculate tan inverse 0.2 omega. Then we calculate tan inverse 0.02 omega. Then finally we calculate pi. So a simple table. Okay. So what are the things we have? We have omega L is 0.5. Okay. We have omega C1 is 5. Okay. Then we have omega C2 is 50. Then omega H is 100. Correct? Okay. So in middle, choose some other values also. Here I choose 1. I choose 10. So that's it. Okay. So how many we have? 1, 2, 3, 4, 5, 6. Okay. So substitute this omega into this expression. This expression. Clear? Substitute each omega into this expression. Okay. So I'm writing those values 5.7, 11.3, 45, 63.4, 84, 87.5. Is there any doubt in this substitution? You can do that using calculator. Correct? Similarly, this term would be like 0.6, 1.1, 5.7, 11.3, 45, 63.4. The second term. Okay, finally keep substituting everything and subtracting from 180, you'll get 174, 168, 130, 106, 50, 30. Okay, so is this clear table? Any doubt in this? Any doubt in this table? Anyone having any doubt? How did I write this? This as this. How did I write that? So this looks like, okay, this looks like A plus JB. Am I correct? What is the angle? Tan inverse B by A. Tan inverse 0.2 omega by 1. So that is tan inverse 0.2 omega. Correct? Any queries here so far? You're giving thumbs up or thumbs down? If you don't understand, please ask me. Okay, so this table is clear. So these are the omegas you have already from the previous omega L, omega C1, omega C2, omega H. Okay, then you are choosing some other two values. Okay, this one as well as this. For each omega, you are calculating first term, second term, and so subtract those two from the 180, you'll get pi. So this is how we have prepared this table. Okay, now, so the important part, okay, so we draw the plots now. Okay, we'll draw a Bode plot. Okay, so while drawing, if you get any doubt, you can ask me. Okay, so this will be omega. Okay, this will be 20 log mod z of c omega. Okay, so again, this will be omega, and this will be angle z of z omega. Okay. So what we do is we choose the values. So zero point 0.5, then 1, 1. So this is omega C1 is 5. Then this is 50. This is 100. Is this values clear? So the list value will choose one more value as zero point 0.1. Okay. So similarly, this is also 0 0.5, 1, 5, 50, 100. Is this step clear? Any doubt? Okay. Now, so let us check this. At uh, we have to check at zero point 0.5, what is the magnitude? Basically, what is zero point 0.5? Omega L, omega C1, omega C2, and omega H. Correct? So at zero point 0.5, omega L, what is our magnitude? The magnitude is, let me go back and check. What is the magnitude? Magnitude is
minus 12.
minus 12. Okay. The next magnitude is 28. Okay. The next magnitude is 48. The next magnitude is 48. Correct. So first magnitude is minus 12. So somewhere here. Okay. Is this clear? So that is the value at this point. Correct. Okay. Next is 28. 28 is the magnitude at which value? At 5. Am I correct? So let's say this is 28. This is the value. Okay. Next, at omega C2, what is the value? 48. Okay. This is the value. Okay. Then 100, what is the value? Again, that is 48. Correct. So let me connect these points. So I'll draw it like this. Correct. So we connect them in this way. Okay. So to put it like, okay, this. Okay. Can you see this now? Okay. So this is slope of 40 dB per decade. So that is first slope from the table. Okay. The, the change of slope is 20 dB per decade. This is 0 dB per decade. Can you see our table? Can you see? What is first slope? 40. Okay. What is second slope? 20 dB per decade. What is third slope? Change of slopes you have to see. That is 0. Okay. So these are the three slopes. Is this clear? Any doubt? So this is magnitude plot. Any doubt in this? Any doubt? Okay. Similarly, we will draw the phase plot. Phase plot we will draw by using these angles. Okay. So first angle is how much? At 0.5, 174. Okay. So 174. Second angle is how much? So let me draw this like this. Second angle is at 1, we have 168. Okay, here. So third one is at 5, we have 130. 5, we have 130. Okay. Then at 50, we have, at 10, we have 106. 50, we have 50. 50 is 50. The last we have is 30. Okay. You can see these values. So everyone. Okay. This will be 50. So the last is 30. Okay, so you can connect the things. So this is Bode. This is the phase plot. Okay, is this clear? Any doubts? Drawing this magnitude plot and phase plot. Any doubts? Any doubts? You can ask me. It's already it took almost 1 hour time. Okay, so you can ask me any doubts. So quickly we'll solve the that is first question. Drawing the Bode plot.
Sir, can you
Yeah.
please explain the phase
Yes.
plot again?
Phase plot. This is our g of j omega, correct?
Yes, sir.
Okay. So for example, how many zeros we have? Two zeros we have. Two poles we have, correct?
Yes, sir.
Okay. So now forget about that for a moment. Just consider this transfer function. J of s is equal to s. Only one zero. Okay. So now in this substitute s is equal to j omega. What do you get? You get this. Okay. So in complex number, how can you write 0 plus j omega? Am I correct?
Yes, sir.
Right. So what is the angle for a complex number? So if you have a plus jb, angle is tan inverse b by a. Okay. What is the angle here? Tan inverse omega by 0. Omega by 0 is infinity, correct? Tan
Yes,
inverse
sir.
infinity means what? 90-degree. Okay. That means if you have a 0, you'll get 90-degree angle. That is the conclusion. Clear?
Yes, sir.
Similarly, if you have a pole at origin, you'll get minus 90. You can verify in the same way. Okay. So
Yes, sir.
here, how many zeros we have? Two
Two.
zeros. So that's why we have this 180. Okay, 90 plus 90. Okay. So how many poles we have? So the poles are two. Okay, but they are not j omega plus j 0. They are something like this is a. This whole thing is jb. Am I correct?
Yes, sir.
So the angle will be tan inverse 0.2 omega by 1. That is this term. Similarly, the other term also this one. Okay, when these angles go up, you'll get negative. Okay, the numerator will be positive only.
It should be tan
Uh,
inverse of 0.2 by 1. So how is it
that's
be
what it is.
negative?
No, 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 no. Here the angle is when it is in the numerator, denominator, this part. Okay, so this angle is tan inverse 0.02 omega. That's correct. Okay, this angle is tan inverse 0.2 omega. Correct. This angle is 180. Am I correct?
Yes, sir.
Okay. Numerator, the zeros are offering 180 degrees. The poles are offering this angle as well as this angle. Okay.
Yes, sir.
Now,
Understood.
cumulatively, these denominator angles go up. They become negative. Okay.
Yes, sir.
So if you want, you can solve this simple thing. You'll try to you'll get to understand. Okay. Take this s of g of s. Take that is as s plus 1 by s plus 2. Okay. So let's say what we do g of j omega. Okay. J omega plus 1 by j omega plus 2. Clear? So what I do this one is j omega minus 2 by j omega minus 2. Clear? So what is this one? I get j omega plus 1 j omega minus 2 by so omega square minus 2 square. Am I correct?
Yes, sir.
So it's not omega square minus 2 square. So j omega whole square. Okay. That will be minus. Am I correct? Okay, just a minute. So that will
Yes,
be
sir.
j omega square minus 2 whole square. Correct? So what is j square? J square will be minus 1. Okay. So ultimately, what do you get here? So numerator we have these terms. Okay. Denominator you'll get what? Minus omega square minus 4.
So,
Correct?
yes, sir.
So in the numerator, if you multiply them, you will be writing them as a plus jb by this one. Correct? Yes or no?
Yes, sir.
So how do I write that? A by this one plus j
B
b
by
by this one. Okay. Now this is your c plus j d. Correct? What is the angle? Overall angle?
it
Tan
should be
inverse
tan inverse of D by
d
C.
by c. Okay. So for the given transfer function also follow the same approach. Okay. So same approach. So this
Yes, sir.
step, which step? This step. Okay, multiplying with this number. Okay. So you
Yes,
will
sir.
end up with this equation. Okay. So without doing all those things directly, we can write it. We will check what are the angles in the numerator, what are the angles in the denominator. We just keep the minus. That also gives the same thing. Okay. But the actual procedure is this. Okay. So simply what we do is numerator zeros angles minus each pole angle. Clear?
Yes, sir.
But the actual steps are this. Finally, you'll get this number as C plus JD only. So single
So
complex number.
in in previous also we have to
Yes,
multiply by the conjugate symmetry.
yes. You have to do this one. Okay. But
Okay,
you
sir.
don't need to do this entire steps. You simply check how many zeros are there. Each zero will offer 180. If the zeros are at origin. Okay. So this one. If the zero is not at origin, okay, it will be like A and B are non-negative. Correct? Then you'll get the different angle. So here, what you'll get here, this one is, I'll tell you. So can you tell me what you'll get answer? You will get answer as tan inverse omega minus tan inverse omega by 2. Is this clear? Is this
Yes,
clear?
yes, sir.
This is the answer you will be getting. So now, just by looking at this, can't I write this one?
Yes, sir.
So that's what I did here. Okay. Any
Yes,
queries? Any queries? Okay, now this is magnitude plot, this is phase plot. That is our first question. Second question is, so let me go back and write down quickly the second question. We need to find the k value. What is j of s given to us? So s square divided by 1 plus 0.2 s, 1 plus 0.02 s. Okay. So basically, gain crossover frequency means, so here if you substitute to j omega, so j omega whole square, so 1 plus, I'll just finish it in 2 minutes. So j omega, 1 plus 0.2 j omega, correct? Okay. So the gain crossover frequency means, okay, so that is the frequency when, okay, so the magnitude will become 1. Okay, magnitude of this entire the transfer function, that will become 1, that at a particular frequency, which we call it is as gain crossover frequency. That means, okay, that means, so 20 log if you take mod z of j omega gc, okay, that will become 0. When you take 20 log of this equation, that will become 0. Okay. Now you just need to check when this is becoming 0. Okay. So now see this. Can you tell me when that is becoming 0? At which frequency? In the magnitude plot. When the magnitude is becoming 0, can anyone tell me? When the magnitude is becoming 0 at this point, correct? So this will be your omega gc. This will be, no, this is becoming 0 at this point, going from positive to negative, not to slope. Magnitude I am asking. Y-axis value is 0 at omega gc is equal to 1. Okay. So now that means, so from figure, okay. So omega gc is equal to 1 radian per second. Okay. So basically this is what, this is for k is equal to 1, because initially we have chosen k is equal to 1 because we wanted to remove k from the calculations. Okay. So now, okay, the given question is, so we want, okay, omega gc is 5. That is our given question, starting question. Okay, starting question is this one. We want our omega gc should be 5. So what should I do? What I need to do? Can you tell me? What is omega gc? When your magnitude goes to 0, correct? So which frequency magnitude goes to 0? Tell me. Which frequency? Omega gc is equal to 1, correct? Yes or no? But we want our omega gc should be 5. What should I do to the plot? Can anyone tell me?
We need to increase the angle.
No. We have to only look at the magnitude plot. What is basically the gain crossover frequency? Gain crossover frequency is something at a particular frequency, the magnitude is 0. That is this one. Okay. Now that gain crossover frequency is 1. Okay. Now I wanted to make gain crossover frequency as this. Okay. What should I do? Tell me. What should I do? Tell me. You can observe this. What is gain crossover frequency? The magnitude should be 0. Correct? To make the magnitude at omega is equal to 5 to 0, what I need to do in the plot? What I need to do? Basically, this point should roll down to this point. Am I correct? No, no, no. The omega gc is magnitude should be 0. Correct? We want our omega gc should be 5. So what should I do? This point, we need to push it here. That means what? Whole plot, what we need to do? The whole plot, what I need to do? The whole plot, I need to push down. Okay. If I push it down, we'll get something like this. Am I correct? Yes or no? That time we'll get 0 here. So now how much push I need to give? How much magnitude I need to push down?
28.
Exactly. 28 magnitude I need to push down. Okay. So that is our answer. Okay. So we want our gain crossover frequency should be 5. At that point, our 20 log. 20 at that point, our 20 log z of j omega should be 0. Correct? So that is the magnitude plot, okay, should be down by 28 degree. Okay, so that means 20 log k, because we are bringing it down, it will be equal to minus 28. Okay, so this is always log 10. Okay, how do you find k? Log 10k equal to minus 28 by 20. Okay, what is k? K is nothing but 10 power minus 28 by 20. Am I correct? So that value will be equivalent to 2.0398. That's our answer. So when you choose k as this much, okay, your gain crossover frequency will become 5. Clear? So this is the definition of the gain crossover frequency. Gain crossover frequency is the frequency at which the magnitude will become 1. Magnitude is becoming 1 means the 20 log magnitude, it will become 0. Okay, when you take log 1 is 0. 20 log 1 is 0. Is this clear? Is this clear? Any doubts? Okay, so since it is already 1.5 hour over, I'll stop here. Okay, and the next live, I'll take problem specific problem on Nyquist plot. Also, I'll do one thing. This material I'll share in the Google Drive, and also I'll share uh, some more problems on the Bode plot, because next live we need to discuss the Nyquist also. Okay, so today itself I'll share some more problems. You can follow the same approach. Okay, so all these steps go for given problem, step 1, step 2, and for each frequency calculate the magnitude. Okay, so choose your omega L, omega H, and also the phase plot. Draw the phase plot like this and answer the extended question. All right. Okay, so I'm hoping there are no doubts. You can still, if you're having any doubts, go through this video. I'll upload now itself. So you can ask me in the discourse. Okay, I'll upload some more problems. Better you solve them and get your queries and ask me in the next slide on Bode plot. Like this plot, I'll explain freshly over there. Okay, not only this, you also watch the professor's lectures, so that there are some of these critical things you'll understand why we take 20 log. Okay, so what exactly the Bode plot and Nyquist plot definitions are. Okay, all right. So thank you. See you on next slide.
Excuse me, sir.
Yes, yes.
What happen if we have some constant in numerator for finding the of 5? Means
Finding of,
5.
yeah, same thing. So you are
We
saying
can write
uh,
directly.
no. Constant will offer 0 degree, no? So take it directly. So example. So let's say your g of s will be, can you see screen?
Yes, sir.
Okay. So you can take g of s as you're saying like 2s by s plus 1, correct?
In numerator also some constants is there in
Oh,
plus
that's
1.
what. That's in the numerator only. I kept 2s.
In numerator, sir.
Huh?
In numerator.
That's what in numerator only I kept 2. Is that okay?
Some constant, some plus constant.
Means
Like 2s
tell me the
plus 1 or
tell me
something
tell me
else.
tell me example. Tell me example.
2s plus 3
2s plus 3. Okay. By
by 8s plus
8s plus
6.
6. Take something else. 7s minus 3 also. Okay.
Yes, sir.
So everywhere it is simple. If you substitute j omega, you will get j omega 2 plus 3. Okay. So j omega 8 plus 6. Substitute to j omega in place of s. J omega 7 minus 3. Clear? Okay. So first what you need to do is, okay. So first multiply these two things. The regular procedure I'm saying. Okay. If you multiply these two things, okay, and you have j square is equal to minus 1, you also use that. Okay. So this thing you will be writing like a plus, okay, jb. Am I correct?
Yes, sir.
So in the numerator already you have c plus jd. Okay. D here is omega 2. Got it?
Yes, sir.
Okay. So you can follow the same approach. This approach only. You are ending up with like
At that
this.
time, we can't write the
Ah, ah.
by using the shortcut, right?
No, 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 no. Every time you can write the shortcut. Now this is regular procedure. Okay. Now the shortcut. Okay. Actually, this is not a shortcut. This is regular method only. So what you do is you see the numerator angles. What do you have in the numerator? This term. Correct.
Yes, sir.
So what is the angle? Tan inverse d by
2
a.
by
What
3.
is d? Omega 2 is d by a is 3. Okay. So then denominators are minus tan inverse 8 omega by 6 minus tan inverse. Okay. So 7 omega by minus 3. Correct?
Yes, sir.
Okay. And you have to be very careful when you get this term minus inside. Okay. What do you mean by minus here?
Yes, sir.
You remember that? So all silver teacups. Okay. When will you get to tan minus? Okay, which quadrant? That you have to apply. Is that clear?
Yes, sir.
So that means like sometimes it will be like minus 180 plus 5. Sometimes it is like 270 minus 5, etc. Hope you understand that.
Yes, sir.
Okay. If you get positive, there is no issue. So all are in the first quadrant. If you get negative, you have to check when tan will become negative. So that thing you have to substitute, not just pi. Okay.
Yes, sir.
So this case you'll get when you have minus here. Okay. If you have plus, there is no issue. Okay. Is this clear?
Yes, sir.
Yeah. So just writing from here to here. First, all angles of the zeros, then each pole angle with minus symbol. Okay. So better you solve the problem which I have explained in the video. Okay. Then you will understand. And also solve the problems which I am going to share now. Okay. So if you get some doubts, you can ask. Okay. All right. Thanks. So we'll stop here.
अरे अनिमेश यूट्यूब लिंक तो सेंड कर भाई हेलो साहिब हेलो हेलो तो बोलो साहिल। हेलो। अरे भाई यूट्यूब लिंक है तो शेयर कर दे भाई। हम तो बोल रहे हैं, आप ही कुछ बोल नहीं रहे। सही है फिर। सरप्राइज क्विज था क्या आज? ओके बाय। यो कुछ नहीं, यो यो